Hello everybody, and welcome to my first devlog. This is a brand new YouTube channel to show my progress on my personal projects. I'm hoping that I can find people that are inspired and like the stuff that I'm creating so that I can be motivated to finish a few of my projects instead of just constantly starting new ones. And mostly, I just want to share what I've learned along the way and help people to know what I've come to know that could help them out. I hope you enjoy this video, as it took quite a bit of time for me to figure out how to get the first one together, and I'm looking forward to improving the process as I continue on. This coding adventure started out with Midjourney, which is a popular AI art generator that at the time added a new tile flag. This flag made it so that all of your generated images were tileable. You could place them next to each other and they would be seamless. This feature was really awesome, and I just was excited to hear about it, and I instantly thought about how could I use this for my game. I thought about using it for rock textures and other various applications, but the one I was most excited about was using it for nebulas. And so I started creating nebulas out of these cool tiles, and I'll show you real quick how you can tile them next to each other, and it's pretty much seamless, where you can hardly tell where the overlapping lines are once you zoom in. After I got my generated nebulas, I jumped straight into Godot. In Godot, you can change the background through the environment and its sky property. The sky is generated through something called a shader. There's a few built-in defaults, but none that would quite suit my needs. So I had to learn how to create my own. And that's most of what this video is playing around with Godot shaders and figuring out just how they work and how you can create cool things with them. The first step to understanding one of these sky shaders is the output. The output is a variable called color. You have to send it a three-dimensional coordinate for the red, green, and blue values, and it will determine what color each pixel should be. So if you just plug in all ones like you see here, you'll get an all white background once you plug it in properly, that is. And if you wanted to change that all white background to, say, be a different color, you can just tweak those numbers and you'll get different amounts of red, green, and blue. But that's not too exciting. Like, we definitely want to do more than just be able to set it to one color. So we have to know how to figure out where each pixel is located. To figure out where each pixel is located, you're given a few helper variables. Eye direction will tell you which direction your camera is facing in X, Y, and Z coordinates from a scale of -1 to 1. And you'll see here you get a nice representation where white is where all the values are 1, red is where the X is 1, blue is where the Z is 1, and green is where the Y is 1, excuse me. And then you'll see it all turns to black when the values become negative. Next, we have the screen UV, and you'll see me get a little bit confused while recording the clip because I thought I typed in sky coordinates instead. But the screen UV gives you the X and Y coordinates of your screen. So as you pivot around and rotate, you'll see that nothing changes. That's because 0, 0 will be the top left corner, and 1, 1 will be the bottom right corner. And then the last one, and the most useful one for our case, is sky coordinates. These give your basically latitude and longitude from values of 0 to 1. So you'll see there our X coordinate will wrap around the side, and then our Y coordinate gets darker as it gets closer to the top of the sphere, and then lighter as it gets down to the bottom. And that's what we have to play with. And the rest of it is we have to pass in variables or do math to figure out how to make each pixel the desired color. And that's what this whole video is about. Another thing that you can use to help you out when creating these shaders is that you can pass in parameters called uniforms. The one that will be the most useful to us is a sampler 2D, which is basically just an image. And then we can use that image to determine what color each pixel should be. So in our case, we'll take the tiled image that we had, and just to make sure that everything's working properly, we'll take the sky coordinates and sample the picture based on our sky coordinates. So at the sky coordinate 0.5, 0.5, we'll sample the middle color of our image. This will cause your single tile to stretch across the screen, which doesn't look very good, but it's a start and is making sure that all the pictures are working. The other thing you'll notice is that we have to take the red, green, and blue values out of it because pictures also come with an alpha value, which isn't supported by the color variable. You can also mess around with these letters and put them in the wrong order if you wanted, which can lead to some pretty weird and funky effects as you switch the reds and blues and greens. And I don't think it's that useful for anything, but it's kind of interesting. And then if you set it all to the same red, green, or blue value, you'll get a black and white image. Next up, I got multiple tiles working. This was a lot easier than expected. I just got 2 variables for how many X tiles you want and how many Y tiles you want, and then just multiplied your X and Y coordinates by how many tiles you wanted. Mathematically, I'm not really sure how this works. I imagine it's because the hidden sampling of the texture function loops around automatically for you, but either way, it's super convenient and nice. The only problem we have with using latitude and longitude coordinates for our square tiles is that up near the top of the world and the bottom of the world, the texture gets more and more compressed, and especially at the poles, we'll get this weird, funky pattern that we'll want to get rid of. I tried several approaches to get rid of this pole pattern at the top of the world. My basic idea was to black it out by using mathematical functions. I first tried absolute value, and that pretty much worked, but gave this weird X pattern. I thought I could smooth it out using a logarithm, which helped a little bit, but then it made the edges of the world, the horizon, super bright, which is a cool effect, but not quite the one that I'm going for. Then I tried using cosine and sine functions. I found out the one that worked best was just to take the cosine of the I direction times pi and then cut it in half, and that would give me the circle at the top and the bottom of the world. I could then change this number to make the circle bigger or smaller based on whatever I thought looked best. This, of course, isn't faded, so we'll get into that next. I first started with just squaring the answer from before, but I got this really weird ring in the sky. I don't really know exactly why. I'm sure if I sat down and figured out what the graph actually looks like, I could figure it out. But instead, it was just easier to keep messing around with the math to see what happened. And so this is just some clips of me playing around with different values and just watching to see how the world changes based on the math that I'm using. Eventually, I got it working and made it so that you could pass in a variable for how much fading you wanted, where between 2 and 4 were probably pretty decent values. And then as I was messing around with it, I wondered what would happen if you put in a negative number instead. And it turns out to make a blinding light at the top of the world, which is kind of fun. And then you can also type in a really large value and it will basically cause the whole top of the sky to go black, which also looks pretty good, but I'll be sticking around to one of those middle values for the game that I'm making. One of the problems that I came across with just using this tiling method was some of the textures would be really obvious repetitions of themselves, and it was easy to spot that the sky was tiling. A few months after I started this project, Midjourney added a vary by region feature, making it so that I could change the center of my tiles and create unique tiles that would all tile with themselves. The process doesn't take too long, and you'll see it now as it's generating it. But what we'll get is 4 tiles that look similar to the one we started with, but with different centers. And as you recall, the parameters before, there's about 4 tiles that stretch all the way across the screen. So we can just take these 4 tiles and then use them uniquely to wrap around our sphere. And to quickly show you how I set it up for my project, I just imported the 4 tiles into my favorite image editor called Sprite, and then I just took the bottom 2, placed them next to the top 2, cropped it, and then imported it into my project as one long rectangular tile. Then with the 4 tiles here, we just import them into the project, drag them over to our shader, and then we set the X tile value to 1/4 of whatever it was before, so in our case 1. And I like the Y value being 2, is what I found out is the best. And now we have 4 tiles with different centers that all tile with themselves and create unique environments that we can generate in a matter of seconds using AI art, or if I wanted to, I could generate my own nebulas in whatever image software that I want and just import them in. After I got the nebulas working and how I wanted them to be, I experimented around with exporting it to reduce the file size. As a PNG, one of these 4 sets is around 7 megabytes, whereas as a JPEG, it's only 1, so 1/7 the file size. And I wanted to see how it looks and if it would be good enough for my game. And the answer is it's pretty close. In some of the denser areas where common colors are, you can see jagged edges. I'm not even sure if you'll be able to see these on YouTube, but they're there and they're pretty hard to notice. So much so that I think the typical player won't notice them, so it's definitely tempting to use them. And I'll probably go back and forth on whether I use it compressed or not. The last thing I noticed was that the color is different in Godot than it is in my image editor. I think this is because the image is a 16-bit image, but Godot expects it to be an 8-bit image. I don't really know too much about it, and it's another topic for me to explore, but for now, they just look good enough. Well, that is it for this devlog. I hope you enjoyed it and have learned something useful for it. I'll close out with a few nebulas that I created using this process and a little bit of a time lapse of just slowly spinning through it. And just want to thank you for your time, and make sure to leave a comment if this is something that excites you so that I'm encouraged to continue to make more videos. Thanks so much. This is me signing off.